This is for completing the reaction 9 AS Chemistry, Advanced Studies Chemistry. We'll be skipping around. Your worksheet should be in your packet, so find completing the reaction 9. Okay, looking at number 1, remember that for every single problem that we start, we're going to start looking at this box first. So if there's two things before the arrow, you'd check the synthesis list. If there's one thing before the arrow, you would check the decomposition list. So there are two things before the arrow. So we're going to check the synthesis list. We already know that it cannot be a decomp because there's only one thing for the arrow, in front of the arrow for a decomp. So we're checking to see if it's any of these. Basically then you're looking to see if you have CO2, H2, or O2, because both of these have to be true to make this. So let's go see if we have CO2, H2, or O2. We do not. Therefore, it's not one of these. So then the next choice is to use what we call the activity series chart. Okay, this thing right here. Okay, and we use this if it's an element or a compound. So we use this to start every single problem. If it's an element or in compound, it doesn't matter if it's compound element or element compound. If you have one of each before the arrow, you're going to go to the activity series chart next. So we're going to go back to the example, who's alone? A lithium. Lithium is a metal. It's got to replace the metal part because metals replace metals, and gold is the metal part of the compound. So we will go to the activity series chart, and we're going to say that lithium is alone. So lithium is trying to kick out the other metal, in this case gold. Lithium must be higher than gold, and lithium is in fact higher than gold. Think of this as a hierarchy, right? Lithium's the most powerful, gold's the weakest. So then on this side, because lithium is higher than gold, then lithium is going to go where gold was, and gold will be kicked out. So remember that there's two parts here, this part and this part. You can think of this as the positive side and the negative side, right? So lithium goes and replaces the positive side. Now on this side, we always have to do one of two things, either crisscross reduce or Brinkerhoff. For every piece on the right-hand side, we always have to consider that. I know this is a +1 and a -1. I looked them up on the ion sheet, so they're good to go. And then AU is not a Brinkelhofer, so it will stay like that, and then you need to balance. I will not be going over balance in this presentation. I expect that you know how to balance. Okay. We're going to skip now to number 7. Here we go for number 7. So again, we're going to check the box here. And there are two things before the arrow, so let's look at those two things again. I went too fast. So we're looking for, does this end in a CO2, H2, or O2, or does it have CO2, H2, or O2 in it? It does not. So let's go back and look and see. We have a compound and an element. A compound and an element, doesn't matter which way they're ordered, we have one of each before the arrow. So therefore, because we have one of each, the next place we go is the activity series chart. Let's talk about who is alone. Br is alone. Okay, Br is a non-metal, or it forms negatives. You can look at it either way. So Br is in the non-metal column. It has to be higher than what it's trying to kick out, and it is trying to kick out iodine. Let's talk about why it's trying to kick out iodine. Remember that this is really two pieces, the plus piece and the minus piece, right? Bromine must kick out something like it. Bromine's a non-metal. It has to try to kick out iodine because iodine is a non-metal. Let's see if bromine is more reactive, or as we like to say, more powerful or higher. Bromine is higher than iodine, so a reaction does take place. So then I put Mg with Br, and then I kicked out. Notice I brought over just the pieces, right? The ions. Mg is an ion, Br is an ion. The 2 here and the 2 here come from the rules of crisscross reduce or Brinkelhoffs. So bring over just the ions. What I mean by that is magnesium is an ion and bromine's ion looks like this. That's the parts I can bring over. I'm going to crisscross reduce, so the 2 goes down here. This is by itself, so I have to think about Brinkelhoff yes or no, and that's a yes. And then you'll need to balance. We're going to go to example 10 next. So here we have one thing before the arrow, so let's go check our chart, because remember we always start here. The only three I can look at is here because these have two things before the arrow. So the first two we just did had two things before the arrow. That's why we checked the synthesis area. This only has one thing before the arrow, and it does not fit any of these criterion. So therefore, it's just what I call a simple decomp, and it's just going to be breaking down. So Mg plus O. So I break it down into its elements. Because they're elements, I have to do Brinkelhoff. Brinkelhoff no, Brinkelhoff yes, and then you're going to need to balance. We're going to go to 8 next. So here we have two things before the arrow. Let's check to see if it's on our synthesis list. It is not. It's none of those two things. I don't have an XO, XO, or XCl. So that means that it's just going to, and it's two elements, right? So I can't go to the activity series chart. So because it's just two elements, I bring them together as Mn and O. And then I have to crisscross reduce because I made a compound. I know this is -2, and I know this one is acting as a +7 in this case because I tell you so. You're going to crisscross the 7 and the 2, reduce them, nothing to reduce. Always be sure to scratch out your plus or minus or make sure it's clear that it's not part of what you're trying to write. And then balance this, please. We're going to number 3 next. So here we have an element and a compound. Okay, so we always start here. And we're not going to use decomps because we don't have one thing, we have two. We have an element and a compound. And on number 3, you do see that we have a situation where we have something with chlorine plus an oxygen. So it fits this scheme. Remember that I could have subscripts or numbers with X. I can have subscripts or numbers with Cl. Basically, anywhere you see an X, there could be subscripts with the X or the partner with X. So I could have subscripts here. This is just a generic formula. So let's go back and look at that one. Do you see that we have XCl plus an O2? So that path or that template tells us we're going to form XClO3. So in this case, our X is Si, so SiClO3. Now I can't just put this together. I have to think about the charges. I know that ClO3 is a -1 and Si has multiple charges. So I have to figure out what its charge is from my ion sheet. So what I mean by that is, as I look at Si can have multiple charges. Up here, right here, sorry. Had difficulty finding that for a moment for some reason. Okay, so Si can be a 2 or a 4. Remember, if it can have multiple roommates, then assume it could have others, okay, that aren't listed. Sometimes I sneak in those, not on purpose, it's just sort of the nature of the beast. So if it already has positives here, multiple positives, it could have others that aren't on the list. These are just the most abundant. So I need to see which Si this is. To do that, I'm going to go back over here, and I'm going to think about this in this way. I'm going to say, okay, I know that this is what Si is on the left. We're going to assume that the positive charge or the charge carries over. That's not necessarily true in all of chemistry, but we're going to assume that. So then I say, okay, well, chlorine, when it acts as an ion, it looks like this. So then I have 4 of them, because this acts like a single unit with no 4, so that 4 tells me there's 4 of them. So then I'm going to multiply by 4. This gets me a -4. Therefore, Si must be a +4 to start. And if there was anything down here, right, I would divide by, but that's a 1. So that means Si is a +4 on this side. So then up here, what I would do is put parentheses around this and crisscross my 4 and my 1. Nothing to reduce. You just need to balance. Okay, we're going to go on to number 4 next. So the one right below. We have one thing before the arrow. Remember, we're checking this chart. One thing before the arrow. If you notice on number 4, so looking at your number 4, you see this criterion, something with the hydroxide. So if we have something with hydroxide, it's going to form something with that same something with oxygen plus water. So this is like my XOH, and it's going to form XO plus H2O. Now let me take a moment to get this out of the way from our example we did a moment ago. Okay, so in this case we're going to do CO with O plus H2O. Now H2O is written fine, but this is a new relationship. We have to figure out what it is. Cobalt, when you look on your ion sheet, can be a 2 or a 3 at least, so therefore we have to figure out which one we have. And I would recommend, if you don't see it readily, that you go through it like this. So hydroxide normally forms a -1, and this says there's 3 of them, so -1, times 3 tells me that I have a negative 3 on this side, so cobalt must be a positive 3, and there's nothing to divide by here because there's just a 1, so it stays a 3. So then I know this is a plus 3 and a minus 2, so I'm going to bring my 2 down and my 3 down. I don't need parentheses because there's no polys, and then I will balance. All right, we're going to do number 2 next. So here we have this one here, okay, 2 compounds before. So we're still going to check this list because this does have 2 compounds. And if you notice, it's not any of those. And if it's 2 compounds, I don't go here, I go down here first. I check to see, is it a common gas? So when I'm looking at the common gas scenario, I'm looking to see if both the shaded black and the shaded gray are true. This over here is just the pattern that you'll follow. These are the actual sentences or words that you need to think about. So I need to see something with sulfide, and this represents an acid because it's an H plus a Y, or something with a carbonate plus an acid, or something with a sulfite plus an acid, something that starts with an NH4 plus a hydroxide. Okay, so let's go through and see if ours has that criterion. It does not. I don't have a sulfide on either of these. I don't have a carbonate on either of these. I don't have a sulfite on either of these. Neither of these start with NH4. And another hint would be I don't have an acid or I don't have a hydroxide. Remember, to use this chart, both this and this must be true for each to go forward. Because neither of these are both true, then I know it's simply a double replacement. Therefore, if you think about how you look at this, remember this is Ba plus 2 and Cn minus 1, right? Now this, we would have to know that this is, the charge is like this. Now you wouldn't know cobalt's charge. We'll talk about how you know cobalt's charge in a moment, but for now I'm just telling you that's what the pieces are. Actually, let's just go ahead and talk about how we know cobalt's a 3. So that's the same thing where we talked a moment ago, where you're going to have to split this, right? You're going to split this. We looked this up. We said see that it forms a minus 1. There are 3 of them, so cobalt must be a plus 3. So for a double replacement, you're going to switch the fronts or switch the backs, but not both. So what I like to do is anchor my backs and then switch my fronts. So cobalt is going to go with Cn, and barium is going to go with CHO2 minus. Now cobalt we already know is a plus 3 from the other side. We know barium is a plus 2 from the ion sheet, so we're going to crisscross reduce this. We're going to crisscross reduce this one. Bring the 2 down, bring the 1 down, bring the 3, bring the 1 down. I'm going to scratch this out, and then you're going to balance going this direction. Okay, we're going to look at number 5 next. Okay, number 5 is what we call a hydrocarbon. I get that, so this is the word I'm saying, hydrocarbon, because of hydrogen and a carbon piece. So if you have a hydrocarbon plus an oxygen, okay, and oxygen, remember, if it's written in words, if this was written like this, we'd have to make it a diatomic because oxygen's on my list as an element. That's one of the 7 Brinkelhoffs or diatomics. So if we have a hydrocarbon plus an oxygen, you don't look at the sheet, you have to have memorized that it's going to make CO2 and H2O. And then you're going to balance it. So again, if you have a hydrocarbon, a carbon hydrogen, it could be other things, but you have a carbon hydrogen start plus an oxygen, you have to memorize it makes carbon dioxide and water, CO2 and H2O. Okay, we're going to go to 31 next. Okay, so we have words this time. We're looking at hydrochloric acid. So hydroics come from ide. So hydroics go to ide. And then chloride would be what we have here. And chloride is Cl minus 1. Remember, acids start with a hydrogen. So we're looking at HCl. 1H because it has a minus 1 charge. This is a plus 3 because it says so, and this is a minus 2 as I look them up. So this is Mn2S3. So I'm going to start like we always have. Because it's not a combustion, I'm going to start here. I don't have either of these 2 pieces as my start. Because it's 2 compounds, I'm going to go down here. I'm looking here for something that ends with a sulfide, a carbonate, a sulfite, or starts with an NH4. I see something that ends with a sulfide. So that's a possibility that it could be a common gas. So I'm going to go over here. I have a sulfide plus an acid. Let's check our list again. We have a sulfide plus an acid. Doesn't matter what order we add them, as long as we have both, then we're going to follow the criterion that we see on this chart. So we're going to do H2S and X and Y. So let's talk about what this is. So over here, this is X with the sulfide, and this is H with my Y. It's just written backwards from the list. Doesn't matter how we write it. So this is going to be H2S plus XY. So Mn and Cl. This is fine written because you get it right off the sheet, but here you have to think about the charges and how they go together. Oops, that's a -1. So we know Mn's a +3 already, Cl's a -1, crisscross reduce, and we have a 3 there, and then you'll need to balance it. All right, we're going to go back to number 11. All right, so here we have two things before the arrow, so we need to check our decomp synthesis chart. So we're checking here, and we're seeing if we have either of these criterion. Okay, I do not have any of those. Okay, I have something with Cl, but I don't have an O2, so it's not a synthesis. So because it's two compounds, here was element compound, here is compound compound. I got to check for the list. I don't see an S ending. I don't see a CO3 ending. I do see an SO3 ending. So I see an SO3 ending, but I do not see an acid. Let's go back and look at that. I see an SO3 ending, but I don't see an acid. It doesn't start with hydrogen. Therefore, it is not a common gas. Instead, it is a double replacement. So we're going to anchor the backs. SO3, we know this is a -2. And Cl, we know this is a -1. IR, pardon me, IR is going to go there. MO is going to go here. Now, we got to figure out what the charges are because these could be all kinds of different charges. So we do that method that I showed you back a while ago. We know this is a -2 from the ion sheet. We know there's 3 of them. So therefore, this is a +6, and there's nothing to divide by. It's a 1, so then we know this is a +6 on this side. We have IrCl4. We split it. We know Cl, as an ion, forms -1s. This is what it would look like. So there's no 4. That tells me I multiply by this 4. And this is a +4. There's a 1 here. And so therefore, I know this is +4. So we're going to crisscross. I bring the 4 and the 2 down. Right, so I'm going to show you this because we haven't really done this yet for a bit, 4 and 2. Then we reduce. We haven't had to reduce yet. This is going to reduce down to a 1, and this is going to reduce down to a 2, because this would have been 2 divided by 2, and this would have been 4 divided by 2. All right, so let me clean that up some. So this was a 2, and this is gone. Cross those off. So this is 6 and 1, so I'm just bringing my 6 down, and then you're going to need to balance. Okay. Let's go back to number 14. Or let's go to number 14. I guess we're not going back. Okay, so we have two pieces here. So an element and compound. So we're going to look at our chart here. This is where there's 2, and I don't have that criterion. Okay, I don't have, for 14, I don't have a CO2, an H2, or an O2, so therefore I know I'm going to use, because it's an element and compound, I'm going to use the activity series chart. Okay, I'm going to use the activity series chart. I'm going to see who's alone. Sodium is alone. Can sodium replace nickel? Why sodium for nickel? Because remember, metals try to kick out metals. Okay, or positives kick out positives. You can look at it either way. So let's see if sodium is higher. We have sodium right here and nickel down here, so sodium in fact can kick it out. So therefore sodium goes with the ion that nickel was with, and then nickel is by itself. Remember that this is really this. This is split like this, so this is my positive and my negative. Okay, so here I got a crisscross reduce. We know this is a +1 and this is a -2. So I'd put parentheses around that. That Na should be outside the parentheses, got a little sloppy there. And then nickel, Brinkelhoff, yes or no would be a no, and then you're going to balance it. Okay, so now we're going to go to number 20. So here we have number 20, and it's in words, so we got to first think about how to crisscross reduce that. So this would be IrCO3 2. I'd bring the 4 and the 2 down, I'd reduce it. I know this is MO3 plus and Br1 minus. So crisscross reduce that. There's no reducing on this one. This is just a crisscross because 3 and 1 can't be reduced. Now, we have 2 compounds, so we got to check our list. Is it one of these 2 compound scenarios? Okay, where we don't have a CO2 and H2 or an O2, so it's not a synthesis, but because it is 2 compounds, I got to check this list to see if it's a common gas before I make it a double replacement. Do either of those end in S? No. Do either of them end in CO3? Yes. Let's go back and look. This ends in CO3, but it has to be plus an acid. This is not an acid. Remember the chart says it's got to have CO3 plus an acid. That is not an acid, so therefore I know it's a double replacement. So therefore I know I'm going to have CO3 and Br, I'm going to trade. So MO is going to go here, IR is going to go here. Think about their charges from the other side. So this is going to be 2, it's an O, and this is going to be 3. IR is a +4, BR is a -1. Oops, don't need parentheses. Just bring the 4 down, no parentheses. Okay, and then you need to balance it. Okay, we're going to go up and do 19 next. So here we have words. So we got to think about what the charges are. So we look them up. We know SR BR2 plus F. Okay, crisscross reduce. A single word, we're going to have to Brinkelhoff yes or no. That's a yes. Okay, so we're going to see who's alone is fluorine. Fluorine is a nonmetal. It's going to kick out the nonmetal part of this, which would be bromine. Another hint is they have to be in the same column to be able to battle each other. Fluorine is higher than bromine, so it will kick it out. So therefore, strontium goes with fluorine, and iodine is left alone. Here we have to crisscross reduce. We know this is a +2 and a -1. So that gets a 2. This doesn't get a 2 because of Brinkelhoff. That gets a 2 because of crisscross reduce. The only time I can apply Brinkelhoff is if they're all by themselves. Iodine is by itself, and it is a Brinkelhoffer, and then you'll need to balance. Okay, we're going to go to 32 next. Okay, so we have chloric acid. X go to 8. So I'm going to look chlorate up. Chlorate is ClO3 1-. So my chloric acid HClO3 plus, this is going to be a +4 and a -2. So we're going to crisscross reduce that CCCO3. 2, 4 comes down, the 2 comes down, reduce them. So we have 2 compounds, so let's look and see on our list if it is a synthesis. I do not have a CO2, an H2, or an O2. Because it's 2 compounds, I have to check here next. Do I have a sulfur ending? No. Do I have a carbonate? Yes, I have a carbonate plus an acid. So let's check that, and if those are true, then we're going to do that pattern. I do have a carbonate plus an acid, so we know it's going to form, based on this list, CO2, H2O, or HOH plus XY. Okay, so let's look back at this. So this is my HY, and this is my X, CO3. So we're going to form CO2 plus H2O or HOH plus X, in this case TC, and Y, ClO3. CO2 and H2 are perfectly written because we know that they're covalent compounds, so TC, ClO3 has to be evaluated for crisscross reduce +4 and -1. So we'll put parentheses around this and put a 4 down in balance. The example we're going to go over next is 23. So 23, we have one thing before the arrow, and this is a 6. So this is a +6 and a -3. Crisscross the 6, crisscross the 3. When you do that, they're going to reduce because the 6 will come down, the 3 come down. 3 divided by 3 is 1. 6 was here. 6 divided by 3 is 2. So one thing before the arrow, so we're going to check to see if it in fact is one of the decomps, and it is not one of those. Because it's not one of these 3 and there's only one thing before the arrow, then the only thing we can do is break them down to W plus N into their elements. Tungsten is not a Brinkelhofer, nitrogen is, and then you'll need to balance. We are going to go look at number 6 next. Okay, this is a combustion. How do I know I have a hydrocarbon plus an oxygen? You need to memorize that it forms CO2 and H2O, and then you'll need to balance. We're looking at number 16 next. Okay, so 16 is words, so I'm going to do aluminum plus iodine. Because they're element words, I got to think about Brinkelhoff, yes or no. This is a no, this is a yes. So we're going to check our chart. We always check here unless it's a combustion. It is not one of these two things, but it's not any of those criterion. So therefore, the only thing it could be is them coming together as a simple synthesis. So I with Al with I. Remember, we always put the positive first. So this is a +3 and a -1. So I crisscross reduce like that, and then I balance. Okay, the next example we're going to do is 13. We have two compounds, so we got to check the list like we always do. We always check this if it's not a combustion. We do not have a CO2, an H2, and O2. We wouldn't even look at decomp because we have, in our example, two things before the arrow, so this wouldn't even count. We'd have to look at something with two things before the arrow. Doesn't have CO2, doesn't have H2, doesn't have O2. Because it's two compounds, we're going to go to this chart next. Okay, we're going to see, does anything end in an S? Nope. Does anything end in a CO3? Nope. Does anything end in SO3? Nope. Does anything start with an NH4? Yes. So we see that we have an NH4 start, but in order to use this, we also have to have an XOH, something with a hydroxide. We do not have something with a hydroxide, therefore it is simply a double replacement. So we're going to bring over our ions, our negatives. I like to say I anchor the backs and switch the fronts. NH4 is going to go here. Ag is going to go here. We know NH4 is a +1. It's smack dab in the middle of your ion sheet. We know this is a -2. So we'd have to put parentheses around that and put a 2. We know this is a +1 and a -1. Crisscross reduce again. Make sure you cross off your charges or erase them. Don't forget to balance. We are going to go to example 19 next, which we already did 19, so I must be getting back to my list. Hold on just a moment, please. We already did 19, so we're going to go to 9 actually now. Okay, so for 9, I see one thing before the arrow. So I'm going to check my chart and see if it's one of the ones that are one thing before the arrow. Right, it is in fact one of these. Okay, I have something with a chlorate. Let's look at that a little bit closer here. So I have XClO3. Remember, it doesn't matter if there's a number here or here. If I have something with a ClO3, then I know it's going to form XCl plus O2. So in this case, ZnCl plus O2. I know this is a +2 and a -1, so crisscross reduce, and then balance. Up next is in 21. We got to think about the charges. So we have, let me get my pen working here, a +4 and a -2. So crisscross reduce SnO2. I'd bring the 4 down and the 2 down. This is a 4. Bring the 4 and the 2 down. The 2 would go to 1. The 4 would go to a 2 plus water. So we have two things before the arrow, so we need to check this chart. And we have two things, so we check here. And in fact, I do see the XO plus H2O. So let's look at that a little closer. So this is my XO plus H2O. Remember, it doesn't matter if there's numbers. If I have something with oxygen plus water, we know it's going to make XOH. So this is going to be SN with OH. We know SN was a +4. We look up hydroxide to be a -1. So we'll need to protect our OH because it's a poly with a set of parentheses, and then you would need to balance.